Good evening, my dear students. Now I am discussing the solutions of test number 30, that is on thermodynamics. First question. An ideal gas of mass m in state A goes to another state B via three different paths as shown in the figure. If Q1, Q2 and Q3 denote the heat absorbed by the gas along the three paths, then okay, fine. Here you see, for all the three paths, here initial point and final points are what? Same here. So that the change in internal energy is same for the path 1, for the path 2 and also for the path 3, that is. According to thermodynamics first law, we know that delta Q equal to what? Delta U plus of what? Delta W. Of course, this factor is same, so that delta Q is directly proportional to what? Delta W, that is. Because delta U is same for all the three paths. And we know that work done is nothing but area under the curve. Area under the curve. Area under the curve represents area under the curve. Which curve? PV curve represents always work done here. Always work done here. Here in this problem, that is, area under the curve 3, that is, area under the curve 3 is more, that is, you see, that is what it is more here. So that this is Q3 is more, Q3 is what? More here. And this is what? Area under this curve, that is what? Q1 is what? Less. So that Q1 is less than Q2, less than what? Q3. So that first one is the right answer. Okay. Next. Here the PV diagram, the curve is shown like this. Okay. Yeah, okay. You have to identify curve 1 belongs to which gas and curve 2 belongs to which gas. First you should. Here the given gases are helium and neon, argon and all that. Helium is a monoatomic gas here. Helium is a monoatomic gas. But oxygen is a diatomic gas. Oxygen is a diatomic. For helium monoatomic, gamma equal to what? 1.66. 1 point. For oxygen, it is what? 1.4 here. This is first point. Second point is, remember students, here the slope is more for this curve, that is what? Slope is more, that is. Here slope equal to, directly proportional to what? Gamma, that is, we know that. So that slope is more if gamma is what? More here. So that gamma is more for the curve 2, so that then certainly this represents which one? That is, this one represents monoatomic gas. Monoatomic gas means curve 2 is helium and curve 1 is what? Oxygen, that is. Curve 1 is oxygen and curve 2 is what? This one. So that curve 1 and this is what? Curve 2. So that this is the right answer. Next. Of course, problem 3 is almost similar to the problem 2 only, that is. Okay. This is the arrow mark I am trying. Okay. Now, here you see students, the slope always represents slope. We know that the slope here, slope equal to, we know that one, slope equal to, what is that? Minus gamma into what? P by what? V. What is slope here? dP by dV equal to minus gamma into what? P by what? V here. Here the slope is negative, is there? No, this is the negative, that is for this, and for this also it is negative. So that this is theta 1 and this is what? Theta 2, that is. It is an obtuse angle, that is. Why? Because this it is what? Negative you are getting. This is what you are negative. But for these two curve, you are getting the positive, you are getting theta is positive. So that no, this is not a curve. So that it may be, it is B and A are the right answer, C and D are the not at all the answer. So that this is wrong and this is what wrong here. Next is whether which one is represents adiabatic curve and which one is represents what isothermal curve. That is, we know that for this here, for the dP by dV equal to minus P by V is there for isothermal curve. It is for isothermal curve. For adiabatic, we know that dP by dV equal to minus gamma into what? P by what? V. What you understand here, it is for adiabatic. It is for adiabatic. That means slope of adiabatic curve is more than slope of what? Isothermal curve. It is what? Isothermal curve. How many times greater here? Gamma times it is greater here. So that since the slope is more for curve A, it is slope is more for curve A. So that this curve A represents adiabatic. This is adiabatic. This is isothermal. That is isothermal. So that A is adiabatic and B is what? Isothermal. So that this is the right place. For problem number 3, C is the right choice. Next. Heat energy absorbed by a system in going through a cyclic process shown in the figure is not okay. Volume is in liter has given and here it is in what? Pascal has given. That is okay, fine. Now for the close, it is what? One complete system. That is, now it is started from this point and then ended here. So that for this delta U equal to what? 0. Because initial state and final state both are what? Same only. That is, according to thermodynamics first law, delta Q equal to delta U plus of what? Delta W. This quantity is 0. So that delta Q equal to what? Delta W. What is delta W? It is area under the curve, area under PV diagram, area under PV diagram. This we know that. Since area is a circle, we know that area of the circle is equal to what? Pi r square. So that delta Q equal to pi r square from this point to this point. You see, this one. That is, it is 30 minus of what? 10 divided by what? 2. That is because it's a diameter into liter is there. Now I want to convert minus 3 this way. Next, for this curve, that is for this curve, this line, this one and this one, this also 30 minus of 10 divided by what? 2. That is because we know that area equal to what is the formula? Pi into what? R square. We know that. Into, it is in kilopascal is there, it is 10 to the power of what? 3. Is. Now translate this delta Q equal to pi. Okay, 30 minus 10 is 20 by 2 is 10 into what? 10. Of course, this minus 3, this plus 3 get cancels, equal to 100 pi into what? 100 pi joules. 100 pi joules. So that 100 pi means what? 10 to the power of 2 pi joules is the correct choice. Next. A thermodynamic system undergoes a cyclic process A, B, C, D, A. So that like this. A, B, B, C, C, D, and next is what? A. This is the system. It is going. Here you say, in this part, it is in anti-clockwise direction. In this part, that is okay. In this part, this is in what? Clockwise direction is that. This is like this. It is what? Clockwise. And since area under this curve, area of this and area of this, both how they are equal equal, and also what the direction is what? Opposite. So that net work done equal to what? 0. For this, work done equal to 1 by 2 into base into what? Height. This also work done equal to 1 by 2 into base into what? Height. Magnitude is same, but here anti-clockwise, so that this will be what? Negative. This will be what? Positive. So that net equal to what? 0 here. Net work done equal to what? 0 only. Okay. Now, next question. Can two isothermal curves intersect each other? Curves cut each other? Never. Yes. Option C is they will cut when temperature is in degrees Celsius. Yes, when temperature is in critical size. No. Here they never intersect. Just like a electric lines of force. Similar question. Any two electric lines of force or magnetic lines of force will intersect? No, it will not intersect. What is the reason is when they are, if they intersect now, if the two curves are intersect, because this is at temperature is what? T1 and this temperature is what? T2. That means at the point of intersection at equilibrium, the system should have two temperatures, but it is not possible. Always under equilibrium condition, the system should have only one temperature. Only one temperature. So that here intersection is not at all possible. That is so that A is the right choice. I given the answer also. Why it is not possible? Because under the equilibrium condition, no two, that is under equilibrium condition, there is only one temperature is there. No two temperatures are possible. That is. Next. Okay. Next question. In an isothermal expansion, internal energy of the gas increases, internal energy of the gas decreases, remains unchanged, and average kinetic energy of the gas molecules decreases. Here, isothermal means what? Temperature is constant. In this process, temperature remains constant. This is first point. Second point is what? Internal energy is the function of temperature. Internal energy is the function of temperature. Is the function of temperature. That means if temperature is constant, internal, there is no change in internal energy. That means delta U equal to 0 because there is no change in what? Temperature. So that decreases, internal energy remains what? Unchanged. So that this is the right choice. Next. Read the sentence. In an isothermal reversible expansion, if the volume of 96 grams of oxygen at 27 degrees Celsius increased from 70 liter to what? 140 liter, because it is the expansion, that is. Here, mass equal to what? 96 gram. Okay. Which one here? Oxygen gas. Here gas is oxygen. Gas is oxygen. Okay. Temperature equal to what? 273 plus of what? 27 equal to 300 Kelvin. Temperature. Then volume equal to V1 equal to 70 liter. Then V2 equal to how much? 140 liter. So that volume will be doubled, that is. Okay. What is the work done? Which process it is? Isothermal process. We know the formula for the isothermal process. Work done equal to, the formula is work done equal to N RT into log to the base of E into bracket of what? V2 divided by V1. Recall it. V2 by what? V1 it is. Okay. Substitute work done. But N equal to what? Number of moles. N equal to We know that m divided by m is mass of the gas. How much it is? 96. And that here the oxygen molecular weight is what? 32. That is 32. So that you substitute this and all this. Here 96 divided by 32. 3 2 ja 3 3 into R. All answers in what? R. No need to write 8.31 into R into what? 300 into log to the base of E. It is V2 equal to what? 140. It is what? 140 divided by what? 70 is there. Then simplify it, equal to, I think it is 3 into R into what? 300 into log to the base of E of what? It is 2. It is 2, that is. Of course, no need to convert because 70-liter ratio is there now. It will be get cancels and all that. Here, this becomes 3 into 300. It becomes what? 900. 900 R. Where is 900 R? Yes, 900 R. Log to the base of E of what? 2. So that this is the right choice. Next. For an isothermal expansion of a perfect gas, the value of delta P by P is equal to, that is what? Isothermal. Isothermal means PV equal to what? Constant here. Then differentiate P into dV plus V into dP equal to what? 0. He is asking delta P by P. Okay, no problem. That is okay. V into dP equal to minus P into what? dV. Rearrange the terms. That is dP divided by what? P equal to minus dV divided by what? V here. Then which is the equation here? Minus dV by what? V. So that this is the right choice. Next. 10th one. At NTP, normal temperature pressure, 1 mole, N equal to 1 has been, N equal to 1, of diatomic gas here, okay, is compressed. For diatomic, gamma also has given here. Compressed adiabatically to half of its volume, that is, volume is what? Reduced by what? 2. And attains the final temperature 363 Kelvin, that is, volume decreases means temperature will be what? This way. Okay. Here, T2 equal to, by compressing temperature will be increases, it is 363 Kelvin. T1 equal to 273 Kelvin. Okay, these are the data. Next, gamma equal to 1.41, that is, and then R equal to what? 8.31, that is joules per mole per Kelvin. Which process it is? Adiabatically process. Recall the formula for the adiabatic process. For the adiabatic process, work done equal to, we know that, work done equal to R into bracket T1 minus T2 divided by what? It is gamma minus 1. Substitute. This is a numerically based problem here. Equal to 8.31. Initial temperature is how much? 273. Minus of what? 373. Divided by gamma is how much? 1.41 minus of what? 1. You substitute. Then work done equal to 8.31 into what? Minus 100. Because minus y represents, it is work is done on the gas. Okay, divided by what? How much it is? 0.41. That is, by simplifying, you are getting nearly 1815 or 182. That is what? Joules whatever. Here both answers are 1815. You know, 1815. It is a minus sign. Something is missing here. Here minus 1815 is the right choice. Suppose if I make it minus, this will be the right choice. Yes. Question number 10, that is C is the right choice. Minus of 1815 joules. You see, to create the confusion is given both minus and plus has given. Here minus sign. because work is done on the gas here. Okay. Next question. The pressure in the tire of a car is 4 times the atmospheric pressure at 300 Kelvin. If this tire is suddenly burst, that means initial pressure equal to 4P. Final pressure is equal to the what? Atmospheric pressure after bursting. And the temperature T1 equal to what? 300 Kelvin. And this is what gamma equal to what? 1.4. He is asking the final temperature equal to what here? Whenever any sudden process is there, no, that sudden process is nothing but adiabatic process. It is an adiabatic. We should recall the relationship between the temperature and the pressure here. The temperature and pressure relations is like this. Here T2 divided by T1 equal to P1 divided by what? P2. P1 by P2 raised to 1 minus gamma divided by what? Gamma. This is the relation. Or else T raised to gamma divided by P raised to what? Gamma minus of what? 1. Like this also you can write it. If you bring it to the numerator, this becomes 1 minus gamma it will become. This quantity will become 1 minus gamma if you bring it to the numerator, that is. Okay. Now substitute this. T2. T1 is how much? It is 300. Okay. Equal to atmospheric pressure. How much it is? It is 4P divided by what? P raised to 1 minus 1.4 only divided by what? 1.4. So that T2 equal to 300. This P get cancels. It is 4 raised to what? It is 0.4 divided by 1.4 with minus sign here. 304. Okay, this is the D is the right choice. Next. 1 gram mole of a diatomic gas is given. Is compressed adiabatically. Adiabatically, it is compressed here. So that its temperature rises from 27 degrees Celsius to 127 degrees Celsius. Okay. What kind of process it is? It is an adiabatic process. Adiabatic process. Adiabatic process. 1 gram for 30. No. The adiabatic process means work done equal to, just now I did one problem, divided by what? Gamma minus 1 into bracket T1 minus of what? T2, that is. T1 equal to 273 plus of 27 equal to 300 Kelvin. T2 equal to 273 plus of 127 equal to 400 Kelvin. And gamma equal to 1.4. See, all answers, no, not in terms of R. That is, you have to multiply. R equal to 8.31. Substitute all these values. Then W equal to 8.31 divided by, directly I will write, okay, 1.4 minus of 1 into bracket T1 is how much? 300 minus of what? 400. Substitute all these values. Here work done equal to, you are getting 2077.5 joules. 2077.5. To be specific, again it should be a negative. It is negative. You should represent this is negative. Otherwise, then you can click it. That is, none is the right choice. It is the right choice. Of course, in the question paper, 1 diatomic gas is compressed. You say compressed. Compressed means the work is done on the gas. It is supposed to be minus sign. minus sign. I think in the question paper, problem number 12, that is minus sign is missing, that is. So that this is the right choice. Okay. Next, 13th one. 1 mole of an ideal gas expands, okay, volume increases at constant temperature. It means it should be isothermal process. It should be isothermal process. Okay. From initial volume V1 equal to how much? 10 liter. Then final V2 equal to what? 20 liter. That is 1 mole. N equal to what? 1. Temperature equal to how much? 300 Kelvin. Which kind of process it is? It is process is isothermal process. For isothermal process, work done equal to N R into T log to the base of E. It is V2 divided by what? V1. Work done equal to 1 mole into 8.3, you consider, into temperature is how much? 300 into log to the base of E. Volume is how much? This is 20 divided by what? 10. No need to convert liter to meter cube because it's a ratio. This will be get cancels. It is 2, that is. So then work done equal to 1 into 8.3 into 300 into log to the base of E of what? 2. Here log to the base 2 has given here. This is equal to 8.3 into 300 multiplied by what? 0.6931. That is, you multiply all these things, then you are getting nearly 1728 joules. This is the right choice. 1728. This is 1728 joules. Next. Okay. Next. A Carnot engine is a reversible engine. Yes. Operating between the two temperatures T1 and T2. Yes, this is also right. It has 2 isothermal process and 2 adiabatic process, so that whole answer is right. All of these is what? Right. Carnot engine. The right answer is yes, students. Next. A Carnot engine whose efficiency is 40%. Efficiency E1 equal to 40%. Good. Takes a heat from the source maintained at a temperature of 500 Kelvin. So that source temperature means T1 equal to, please identify source. Whenever you use the word source means it is T1. It is desired to have an efficiency of 60%. I want to increase the efficiency equal to 60%. Okay. Then the intake temperature for the same exhaust, that means sink temperature is same. T2 is same. Here also it is what? T2. T2 is not changed. But to increase the efficiency, what is T1 dash equal to what is asking? Please understand the question, that is. Here to increase efficiency can be increased by 2 ways. One is T1 can be increased or T2 should be what? Decreased. But in this situation, the T2 is remain same in both cases here. Now I will write 2 equations. I will write here, that is here efficiency equal to 1 minus T2 divided by what? T1. Okay. Now I will alter it. T2 by T1 equal to 1 minus of what? Eta 1 I am writing. First calculate T2. T2 equal to T1 into bracket 1 minus of what? Eta. What is this one? Equal to 500 into bracket 1 minus of what? 40% means 40 divided by 100. What is this one? T2 equal to 500 into 60 divided by what? 100. Yes. Then which get cancels here? This 0 get cancels here. this is equal to 300 Kelvin is the sink temperature. So that here also it is what, 300 Kelvin only, it is 300 Kelvin. Now I want to calculate T1 dash, I have to calculate. Okay, fine. Now next, eta 2 equal to 1 minus T2 divided by T1 dash, I am writing. Substitute this, T2 divided by T1 dash equal to 1 minus of what, eta 2 equal to 1 minus 60 divided by what, 100. This is equal to 40 divided by what, 100. And this is T2 divided by T1 dash. T2 value we know that. Therefore, T1 dash equal to T2 into 100 divided by what, 40. Substitute. This T1 dash equal to, what is the value of T2? 300 is there. 300 into what, 100 divided by what, 40. Then simplify it. Then you are getting this 0 is a cancelled here. This becomes 3000, yes, 3000 divided by what, 4 here. So that 3000 by 4, 3000 divided by 4 equal to 1, that is 750 Kelvin. This is the what, T1 dash equal to. So this is the right choice. Next, 16th. A Carnot engine takes 900 kilocalories of heat from a reservoir. That means Q1 equal to 900 kilocalories. This is nothing but, kilo means 9 into 10 to the power of 5 calories. Okay, fine. Next, reservoirs means source. T1 equal to 273 plus of what, 723 equal to, how much it is, 996 Kelvin. 996 Kelvin. Then exhaust to a sink temperature means T2. T2 equal to, what is that here, 273 plus of what, 30 equal to 303 Kelvin. So that now very good numbers has given, no problem. That what to be calculated here, work done by the engine in calorie is, okay, work done equal to formula equal to Q1 minus of what, Q. This is the one formula. Okay. To calculate work done, I need Q1 and Q2. Of course, Q1 is now, but I don't know Q2. I don't know that how to calculate. Bring the relation between the Q1, Q2, T1 and Q2. That relations we know that Q1 divided by Q2 equal to T1 divided by what? T2. Yes, calculate. Therefore, Q2 equal to Q1 into T2 divided by what? T1. Substitute. What is Q1? Q1 is 9 into 10 to the power of what? 5. T2 is how much? 303. Got. And T1 is how much? 996. I think 303. This one. This comes around. It is 2.73 into 10 to the power of what? 5 calories. This. Because roughly it is 9 by 100. That like that you calculate 2.73. Now work done equal 10 to the power 5 is common here. So that 9 minus 2.73 into what? 10 to the power of what? 5. That means 6 point something that you is supposed to get. 6 point something means this is the right choice. 6.73. 27 into 10 to the power, because 9 minus 3 nearly. Next, 17. If a Carnot engine is working between the steam point and ice point, steam means what? It is a high temperature. T1 equal to 100 degrees Celsius, water will be boils here. So that 100 plus of what? 273 equal to 373 Kelvin. And ice means it is 0 plus of what? 273 equal to 273 Kelvin. Then find the efficiency. Simple. Efficiency equal to 1 minus T2 divided by what? T1 equal to 1 minus, it is 273 divided by 373. This is equal to, that is 100 divided by what? 373. Then if you calculate the percentage wise, you are getting what? 26.8%. So that this is the right choice. Percentage means multiply what? 100, you have to do it. Next, 18. The volume of air increases by 5%. So okay, delta V increases by 5% in its adiabatic expansion. The percentage of decrease in its pressure, as you know that in the PV diagram, as pressure increases, volume decreases, or as volume increases, the pressure is what? Decreases. Okay. Here, which process it is? Adiabatic process, because it has given the what? Gamma value has given, and also here adiabatic process is mentioned. We know that PV raised to gamma equal to constant. Differentiate. P, I will differentiate this term, gamma into V raised to gamma minus of 1. Okay. Into what? dV plus, I will keep this term as it is, V raised to gamma into dP equal to what? 0. That. He is asking what is the percentage of decrease in its pressure has given. No? So that modified dP by P equal to dP by P equal to minus gamma into bracket dV by what? V, that is, we know this standard equation, that is, we know this. Okay, this is equal to minus gamma value is how much? 1.4. Okay, dV by V, it is 5%. 5%. This is what? 5%. Then we calculate 1.4 into 5 equal to what? Minus of what? 7%. This is the what? 7%. Here already decrease, the minus sign represents what? Decrease. So that no need to give minus 7 here. That is. Next, 19th. The temperature of a hypothetical gas increases to square root of 2 times when compressed adiabatically. The temperature of a hypothetical gas increases to square root of times when compressed adiabatically to half of its volume. What is the equation? That is, okay. Here we have to bring the relation between temperature and what? Volume, that is. Temperature and volume, that is. In adiabatic, the relation is T1 V1 raised to gamma minus 1 equal to T2 V2 raised to what? Gamma. Always we should remember the 3 equations are there for the adiabatic: PV, TV and what? Pressure and temperature. Okay, fine. Now T1 divided by T2 equal to V2 by V1 raised to what? Gamma minus of 1. We know this. Here the temperature increases to T2 equal to square root of times of what T1 is. Okay, now I am writing T1 divided by square root of 2 times of what? T1 equal to V2 divided by V1 raised to what? Gamma minus 1. Okay. Here this T1 get cancelled. It is 1 by square root of 2 equal to compress adiabatically half of its volume. That means V2 equal to V1 by 2 it is. So that can I write V1 by 2 divided by V1 raised to what? Gamma. So that this V1 get cancels. It is what is left? 1 by 2 raised to what? Gamma minus. Now this term can I write like this? 1 by 2 raised to half. Can I write like this? Square root of 2, nothing but what? This way. And 1 raised to what? Anything power equal to what? 1 only it is. Equal to 1 by 2 raised to what? Gamma minus of what? Compare the power. This is off. This is what? Gamma minus 1. So that 1 by 2 equal to gamma minus of 1. Therefore, gamma equal to 1 plus 1 by 2 equal to 3 by 2 it is. 3 by 2. 3 by 2. So that we know the equation PV raised to gamma equal to constant because it is adiabatic. So that PV raised to what? 3 by 2 equal to constant. So that which is the right equation? This is the right equation. A reversible engine converts 1/6 of heat input into what? Work. Okay. That means efficiency E equal to 1 by 6. This is the meaning of it. When the temperature of the sink is reduced by 62 degrees Celsius, sink initial here T1 we don't know that is T2 then next is sink temperature is reduced, so that efficiency is what? Doubled. Efficiency equal to 2 times of what? Eta 1 equal to 2 by what? 6. But sink temperature T2 dash equal to T2 minus of what? 62. That is students. No need to convert into Kelvin, just substitute what? Minus of what? 62. The temperature of the source and sink are, but here T1 and here also T1 will be remain same only. That is not altered source temperature. I will write two equations. I will write eta 1 equal to 1 minus T2 divided by what? T1 it is. Here you see eta 1 equal to what? This is equation number 1 I will write. This I will write equation number 2 I will write. Next, second time eta 2 equal to 1 minus T2 dash divided by what? T1 I will write. This is equation number 3. What is T2 dash? You know that? Equal to 1 minus of what? T2 minus of what? 62 divided by what? T1. That is. This you call as equation number 3. Now simplify it. Eta 2 equal to, can I write like this? Expansion 1 minus T2 by what? T1. Minus plus of what? It is 62 divided by what? T1 here. Students, you see this part 1 minus T2 by T1 is nothing but what it is. Eta 1 is there. So that this one, eta 2 equal to what? 2 eta 1. That is 2 eta 1 equal to eta 1. Okay. Plus of what? Plus of 62 divided by T1. I hope that you understood this. Because efficiency second time it is what it is, doubled here. So that subtract this one, eta 1 equal to 62 by T1. But eta 1 is known here, 1 by 6, we know this. So that 1 by 6 equal to 62 by what? T1. Therefore, T1 equal to 6 into 62 equal to, it is 1, that is, this becomes 372 Kelvin. This is the 372 Kelvin. But all choice are in what? Degree Celsius is there, no? So that 372 minus of 273, that is 9, that is 9, it is 0. 99 degrees Celsius, 99 means there is only one. No need to calculate 37 days, because there is 99 is what? Only one choice is there. Okay. But once you know this T2 value, then T1 value, we can calculate T2 also. We can calculate by using what? This equation we can calculate here. Okay. You try it yourself. Next. 21. A refrigerator with coefficient of performance beta equal to what? 1 by 3 releases 200 joules of heat. Release means always in the refrigerator, heat is given out of the system, that is more, that is Q1 equal to what? 200 joules. Remember these words. Heat is rejected by the refrigerator because inside temperature is what? Low. So that Q2 is what? Low. Then heat to a hot reservoir, then the work done he is asking, that is okay. We know the equation, beta coefficient of performance equal to Q2 divided by what? W. This is equal to Q2 divided by Q1 minus of what? Q2. We know that W equal to Q1 minus of what? Q2. Even in the car notes, heat engine. You know the value of beta, it is 1 by 3 equal to Q2, I don't know that is, Q1, I know this, 200 minus of what? Q2. So that 3Q2 equal to 200 minus of what? Q2. So that this becomes 4Q2 equal to 200. Therefore, Q2 equal to 200 divided by 4 equal to 50 joules. Anything wrong? Am I made any mistake? 1 by 3 coefficient of performance. It is 200 minus of what? Q2 equal to 3Q2. 3Q2 equal to, it is 250 joules. Okay. But what we want to calculate here? Work done here. Work done equal to Q1. Q1 is how much? 200 minus of 250. This is equal to 150 joules. Where is 150 joules? Is the right choice. 22nd. Oh. If the door of the refrigerator is kept open, always the room is heated. I told you it's conceptual based question because the work has to be done more here. Normally, when you are turning the car, that is, suppose AC is on, if all windows are open, then the work done by the engine will be what? Always it is more here. That's why we are closing all the windows, we are closing now like that. Next, 23. Okay. Remember students, in this diagram, he is asking work done by the path AB. That is what? Path AB like this. He is asking. Okay. AB means here, this is the, normally the graph is P against V is there. But in this diagram, The graph is volume against pressure, that is volume against pressure. If it is P against V, like this you are doing, no? That is what? Yes. These are the altitudes. Yes. Suppose it is P again, it is like this. What you are doing here? It is area of the trapezium, that is area of the trapezium. What is the area of trapezium? It is 1 by 2 work done equal to area of the trapezium equal to, this is C, I will call it as this, I will call it D. So that AC plus BD into what? CD. You know the sum of the altitudes into what? Base. Purposefully I given this question here. In this case here, work done equal to 1 by 2. Here, these are the altitudes. This and what? This, students, here. So that this will be EB plus, this is DA, this is DA. Okay. Next is base. Base is, this is the base here. Which is the base here? BC is the base here. This is the base. Into what? BC. Very interesting question it is. Work done. Normally students, what we will do is we are taking these things, we are taking, that is wrong. It is volume against pressure is there. 1 by 2. Yeah, 2. EB. What is EB? This is the EB. Okay. This is EB. EB nothing but what? Pressure we have to take it. What is this value? 2. It is what? 2. Okay. 2. Plus of what? DA. DA nothing but this one. From here to here. It is what? 4. Okay. Into BC. What is BC here? BC is this one. That is BC is this. From here to here, it is 4 minus of 1. It is 3 into. It is in liter, is there no? Liter we need to convert into what? Meter cube. It is minus 3. This is equal, done equal to 1 by 2 into 6 into 3 into 10 to the power minus 2 1 jar 2 3. This is equal to 9 into 10 to the power minus 3 joules. But here both minus and plus both are there. Tell me now, in this process AB means it is an expansion is that it is from 1 to what? 4. So that it should be work is done by the gas. So that this is the right choice. Cleared? Next, 24th. Oh, very interesting question that is. Here PV raised to m equal to constant. Find the value of m, that is constant. Find the value of m, that is. Here by looking to this, m means it is an adiabatic process. In adiabatic process. Recall it. Many questions I solved. dP by dV equal to minus m into what? P by what? V, that is. Students, dP by dV is nothing but slope. It is nothing but slope here. Nothing but slope. But in this problem he has given this angle is given, students. But I need this angle. This angle, that is what? Slope equal to slope. What is that? dP by dV. It represents what? Slope. Slope is negative, of course. Here slope equal to, don't write 37, don't write. It is tan of what? 180 minus of what? 37. Of course, tan of 180 minus theta equal to what? This one. Minus of what? Tan of what? 37. That is. Tan 37, we know this. I told you several times. This angle is 37 degree. 37 means this is 3, this is 4, this is what? So that what is tan 37? Tan 37 equal to 3 by what? 4. Minus sign, why are you getting here? Here 180 minus means this is in the plus plus, minus, minus minus minus. It comes in this quadrant. Sin by cos equal to minus. Then now dp by dv, this is equal to minus of how much? It is 3 by 4. It is what? Minus of 3 by 4 minus m into, okay, fine. From the diagram, what is the value of p here? The p is 2. Volume is how much it is? 4 is there. It is what? 4. Of course, all are in a SI unit. And this minus sign get cancels. 3 by 4 equal to m into 2 by what? 4. This m, 4, this 4 get cancels. Therefore, m equal to what? 3 by 2 it is. M equal to 3 by 2. This is the right choice. Next, 25th. CV and CP are the specific heat at constant volume and pressure respectively. Okay. Has given the comparison of diatomic and monoatomic gas here. First list out CV for monoatomic gas. And next is for diatomic gas. For monoatomic gas, we know that 3 by 2R, then Cp equal to 5 by 2R. For diatomic gas, Cv equal to 5 by 2R and Cp equal to 7 by 2R. Okay. Now you calculate all operations, you do it yourself. What is that? Cp minus Cv, first you calculate. What is Cp minus of Cv equal to 5 by 2 minus 3 by 2. Of course, R is common, equal to 2, that is what? 1R. Next, Cp plus Cv you calculate. Cp plus Cv, that is 5 by 2 plus 3 by 2 R equal to, what is this? 4R. Next, Cp by Cv you calculate. Cp by Cv equal to 5 by 3 it is. Then Cp into Cv you calculate. Cp into Cv equal to, that is 15 by 4. 15 by 4. Okay. Now, next, similarly, you calculate for these things, you calculate. Okay. Yes. Cp minus of Cv equal to 7 minus 5, that is what? R it is. Next, Cp plus of Cv you calculate. 7 plus 5, 12 by 2 equal to what? 6 you are getting. 6R you are getting. Then next, Cp by Cv you calculate. Cp by Cv equal to what? 7 by 5. Then Cp into Cv equal to 35 by 4 equal to 7 point something, that is. Okay. Okay, let it be, that is. Anyway, it is 4, it is 15. This is what? 35 is that. So that Cp into Cv is lower for diatomic gas. No, that is lower for diatomic gas. No, it is wrong. Then Cp minus Cv is more for diatomic gas. No, this also R, this also what? R. So that this is also no. Then Cp plus Cv is more for diatomic gas. Yes, it is 6R and this is what? 4R, that is. So that this is the right choice. What about Cp by Cv? Cp by Cv is more for diatomic gas. Cp by Cv is more for diatomic gas. Is this also more? No. No. Cp by Cv. Cp by Cv. Check it. Okay, we will check it. Cp plus Cv is more for diatomic. Cp by Cv is more for diatomic gas. Okay, yeah. So something is the same. This also Cp by Cv is more for diatomic gas. This also right. Next, 26th. An ideal gas at constant temperature is taken from A to what? B. If Q1, Q2 and Q3 indicate the heat absorbed by the gas along the three paths, delta U1, delta U2 and delta U3 indicate the change in internal energy. Say, students, here the initial point and final point are same. Initial state and final states are same for all the three paths, 1, 2 and 3. So that delta U1 equal to delta U2 equal to U3. So that this is not, this is not. So the choice is either this one or this one, that is either A or B. Now you should identify whether A is right or B is right. And already I told you that is area under the diagram, PV diagram represents work done. So that this area is more, 1. When area is more, work done is more. When work done is more, charge, heat transfer is also what? More here. So that this is the right choice. This is wrong. Next. In an isobaric process of an ideal gas, the ratio of heat supplied Q and work done by the gas is. There are many methods are there for this. Ratio of the what? Heat supplied divided by what? Work done. Q by W is asking. Which process it is? Isobaric. Isobaric means what? The pressure is what? Constant here. So that this is Q divided by W equal to one formula, N Cp into what? dt. I given the chart also there is. Go through the chart, very important. And work done equal to N R into what? dt. So that this N, this get cancels. This is equal to Cp divided by what? R here. What is Cp? We know that gamma divided by gamma minus of 1 into R divided by R. This get cancels. So that this is the right choice. Okay. Because it is an isobaric process. Isobaric means what? Pressure is what? Constant. Next, 28. In thermodynamic process, which of the following statement is not true? That is not true. In an AWD process, the system is insulated. Yes, there is no exchange of heat. Okay, this is right. Then, in an isochoric process, pressure remains constant. No, pressure, which is constant here? Volume is constant. So that this is the right choice. He is asking the not true, that is not true is asking. Then, what would check it? See, in isothermal process, temperature, yes, temperature is constant. And in AWD process, PV raised to gamma equal to what? Constant. So that the wrong answer is this. This is the wrong answer statement. Wrong statement, not wrong answer, wrong statement. Correct statement should be what? Volume should be remains constant. Next, 29. Okay. 2 moles of a gas are kept at temperature 0 degrees Celsius is compressed 4 volume to what? 1 volume here. Okay, work done. It is a negative, students. Of course, here all are negative is given here. Next, here what process here? Temperature is 0 degrees Celsius. It is nothing but isothermal process. Work done equal to N RT log to the base of E into V2 divided by what? V1. Work done. How many moles? 2 moles into 8.31 into temperature is 0 degrees Celsius means 273 log to the base of E V2 equal to what? 4 divided by what? 1. He has given log to the base has given here, that is work done by this one. Here 1 minute, I made mistake. Here V2, the work done in the compressed V2 equal to 1V, V1 equal to 4V, that is, so that this I made mistake here. This becomes V divided by 4V. This V is what? Get cancels. So that work done equal to 2 into 8.31 into 273 into log to the base of E of what? 1 by 4. As given here. This is equal to 2 into 8.31 into 273 into 0.621. Of course, here it is a minus quantity, is that is minus quantity. Now, multiply all these things, then you are getting minus of what? 6359. Minus of 6359. This is equal to minus 36359 joules. Next, 30th one. A sample of 0.1 cc of water at 100 degrees Celsius at normal pressure, okay, requires 54 calories of heat energy to convert a steam at 100 degrees Celsius. Temperature remains constant. If the volume of the steam produced is 167.1 cc, that is, okay, it is a temperature remains constant, that means it should be isothermal process. Work done equal to V into what? dV, that is, yes. Work done equal to 1.01, okay, 13 into 10 to the power of 5 into V2 minus of what? V1, that is. Okay. Here the final volume has given here. Work done equal to 1.013 into 10 to the power of 5. It is 167.1 minus of what? 0.1. Cc has given. Cc, you have to convert into what? Meter cubed. You know that cubic centimeter to what? Cubic meter. It is minus of what? 6. Then this work done, it translates into 16.9 joules. Okay. Then change in internal energy has given. He is asking internal energy. According to thermodynamics first law, we know that dq equal to what? du plus of what? dw. So that therefore du equal to dq minus of what? dw, that is, okay. Now, what is the heat supplied here? It is 54 calories. 54 calories. 54 calories means Q equal to 54 calories. Okay. So that you have to convert into what? Joules. It is 4.2. Because we know that 1 calorie equal to 4.2 joules. Multiply this. 54 into what? This one. This comes around 225.72 joules. Substitute this. 225.72 minus 16.9 joules. Roughly it is 17. The 208 something. So that this is the right choice. Okay. Now I will end my session at this point. Thank you.